For this example, we're going to attempt to freehand draw this piecewise function, and after we're done, identify the domain and range. Before you start freehand drawing any piecewise function, it's not a bad idea to identify key characteristics of each one of the pieces, so you at least have an idea of what you're going to be graphing. This top piece, the -3 piece, is saying that no matter what x is, I always want to be -3. This section is going to be a horizontal line. The next part, x, is simply a linear function with a slope of 1 and an intercept of 0. So maybe we want to make note a slope of 1 and a y-intercept of 0. And in the last part, we have a slope of -1 and an intercept of 0, 6. That's just a cursory treatment of each one of the functions that might be in our advantage to graph when we're graphing. So we'll start with the easy part. That's the horizontal section. That horizontal section is at -3, and it continues at -3 all the way up to and including x is equal to -4. So we're going to start down here to draw our horizontal line. This continues on to the left. Here's our horizontal line at x is equal to -3, and y is equal to -3, and that's going to continue until x is equal to -4. We're going to put our solid dot there because of the equal to on that inequality. Moving on to the next part, we're going to graph the line y is equal to x. Sometimes it might be in your advantage to try these endpoints just to get an idea of where the line is going to start and stop, especially if you know it's going to be a line. If you know that the line has a starting point and a stopping point, it can be in your advantage to figure out those two endpoints, even if you know those two endpoints aren't going to be part of the graph. So in this case, I'm going to have an endpoint at -4, -4, because y is just equal to x, and I'm going to have an endpoint at 2, 2. Now, when I draw those two endpoints, because this is not an inclusive inequality, it's not including -4 and 2, when I draw those two endpoints, I want to make sure that I put my open circle there, and I put my open circle there. And I get my straight line segment that goes through the origin from one end to the other. And for the last point, we can do something similar. X is equal to 2 is the first part of the domain for this last part of the function. So for this last part of the function, we're going to have -2 plus 6, which is 4, which means I'm going to start this graph at the point 2, 4. Substituting in a value gives you a place to start and then allows you to work off of that one point. So we're going to put a point at the spot 2, 4. And then from there, we're going to follow a slope of -1. So from there, we're going to follow down a slope of -1. And we're going to go through each one of the coordinates following the slope of -1. Now, because we have this graph drawn everywhere and we have arrows on both of the ends, we can identify the domain as being all the real numbers. Any real number is eligible to be substituted in and get a value out. The range is where we have a slightly bigger problem because there are some unique situations in this graph that we want to pay attention to when it comes to writing our range. If I follow along this part, the black part over on the left, the horizontal line section, I'm only getting -3 out of that. That's the only value that I have. When I jump to this one, I lose the spots in between. So in between -3 and -4, and I don't even get -4 because of the open circle. I then draw this up, which thankfully picks up the values between -4 and -3, and this graph comes up and then ends at 2. And then from there, I jump from 2 to 4. So at this point, if I'm just going left to right, I don't have -4, I don't have 2, and I have jumped up to 4. But thankfully, this line segment covers a lot of that, this ray covers a lot of that. As this half line starts to come down, it covers up the space between the 2 and the 4. I get those values. It covers up the 2, and then it continues going down. It passes up all of these values, and it gets me all of those numbers that I was missing below that point. So if I'm looking at range values from the bottom of the graph, and I'm looking over here, this line, this half line over on the right is covering everything. All of these values are being hit by that red half line until I get to 4. And once I get past 4, there's nothing happening up here in the range. So when I write my range, I'm going to say y is in the real numbers such that y is less than or equal to 4.